Welcome everyone to the GitHub and Git workshop for IEEE Winter 2022. Woo! Yeah, thank you all so much for coming. A little bit about me. So I'm a computer engineering major, fourth year computer engineering major. I've been in IEEE for all 4 years. When I first joined IEEE, I knew nothing about really anything related to engineering or computer science or computer engineering, electrical engineering. I actually entered as undeclared, and because of IEEE's influence, I was able to switch into computer engineering because I thought it was so cool. So yeah, so if you have any questions about that, or if you have friends who are looking to switch in and need some help, I can probably give them some pointers into that. Yeah, so, but really, like in classes, it really feels like a lot of the time we don't get a lot of experience, hands-on experience with things. A lot of the professors, they do a lot of research-oriented projects, which is really awesome if you want to do research. But I'm guessing a lot of you are hoping to do like hobby projects, or you're hoping to go on to industry and like have a living. Yeah, so you're not just looking at like what algorithm is going to run the fastest. You're hoping to actually gain some hands-on experience that you can use and you can put on your resume. And that's what this workshop is all about. Is it's how do you, and let's say you've like made a few coding projects. How can you now view them or put them out in a way that is familiar for employers so that they can see, oh wow, this is a really cool project, and I know exactly how to learn more about this project because GitHub is such a great place where you can store all of your projects, including like your schoolwork and non-school work and research work, or maybe if you have something for a job, you can just compile all of the code that you've ever written and organize it and make it look all pretty. And yeah, it's just a great tool. And I'm pretty sure that my GitHub was a great reason for why I was able to get an internship this year. Because just, yeah, I make sure to like put it all over my resume, and I'm guessing that they probably clicked on it. I put a lot of time into it. So I'm hoping that you will also put in a lot of time into it. All right, so without further ado, I'm gonna start sharing my screen. I prepared a few slides. Let me post a link to the slides. And actually first, let me go show you the club website. Okay, so this is the club website. So you can see like here are the projects. So here's Mapache and motion recognition project. And then here is the events tab. And so events and workshops. So this has all of the information on events and workshops. And here we have Winter 2022 workshop series. So if you click on this, then you gain access. Oh, okay, there we go. You can see all of the different workshops that will be offered this quarter. There will be 4 of them, GitHub, which you are at right now, 3D printing next week, Bluetooth the week after, and then soldering the week after that, which does not have information yet, but information will be coming soon. And on this website, you can see here are the slides. So you can open these up and cool. So this is the slide deck if you wanted to follow along, or if you wanted to refer back to them a little bit later. And I will be posting this recording. So once you come back to this, you will be able to have a link right here. You can watch this recording if you feel like you need to review on anything that we talked about. Great. Okay. So let's start. Okay. Excellent. Okay. And I threw this together kind of quickly. So sorry if it's a little bit disorganized today, but I'm hoping this can, yeah, I don't know, be kind of fun for all of us. Okay. Cool. So I have a couple scenarios, or a few scenarios here, and I want you to like think through them. Like, let's say you are doing this big coding project, maybe it's for a class, and all of a sudden, like you make one change and then everything breaks suddenly. And actually you can't remember like which parts of the code you changed to break it, and you don't know when the last time you actually had it working is. What do you do in that situation? Yeah, does anyone have, what would you do? Let's say like your code broke, what would you do?
Well, hopefully you would have a somewhat recent backup, and then you could just use that.
Great. Okay. So maybe having like, you have frequent backups of your code, maybe like free app, like back it up or something. Okay. Anyone else have an idea? Yeah. One thing that I think of is just like Control Z, like undo, 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 or Command Z. Yeah, I don't know. And I just keep going back until maybe it works. Yeah, but that's kind of problematic because like, what if you wrote good code, then now you're getting rid of good code. Yeah. Oh, did someone say that? Yeah. And yeah, but it kind of stinks. Like, yeah, and now like you don't even remember everything that you changed. So maybe it's like some line that like is like really obvious, but like you just forgot that you even touched that file. Yeah, it's kind of a problem. Anyways, let's move on to the next scenario. So next scenario is now it's like you have a collaborative code base, and all of a sudden, like the code was working a week ago, but now a whole week passes and a bunch of things have happened, and now you've realized, this one specific part of the code no longer works, and you're not sure at what point in the week or which person caused this bug. What would you do in that scenario? And let's say none of them know like how the bug could have appeared. Yeah, I don't know. Hope that you have backups. Yeah, hopefully everyone remembers every single line of code that they wrote something, and then you work off that. All right, the last thing. So let's say you spend several hours, maybe even hundreds of hours developing a really awesome feature for an app. And then you realize, oh shoot, actually we're not allowed to add this feature until 6 months from now. But I don't really want to lose all this code that I've just written. So I don't want to just like revert all my changes, but I can't push this with like with like the next release. Like I can't push this with like version like 2.6. So what do you do in that situation?
You could like save your code as a separate file, and then you could just like Control Z until the features removed.
Mm-hmm. Yeah, great. But then let's say in 6 months, now there have been a bunch of more changes, and now you're not sure exactly which parts of your code can like slot in to what you've done over the past 6 months. So really, so what I'm trying to show is that each of these three problems, these are very, I would say, very common problems. This is like yeah, of course, like you run into a bug every once in a while. You code something and it's not working, or a group of people are coding and like some random person may miss like one tiny thing in the code, and now it like broke this huge important feature. Totally happens. Out of like code, there's some statistic, it's like 1 in 100 lines of code has a bug on it. And now if you take like Linux kernel, which has like 1 billion lines of code, that's 1 million errors. So I'm sorry, 10 million errors. Yeah. That's like terrifying. Code is hard to write sometimes. Like having testing is hard. And now let's say on top of that, you're also having to deal with the pressure of managing a bunch of people all at once, or working with yourself and like forgetting something from like a couple hours ago, from like a week ago. Yeah, so code overall is just really hard to write. So the whole purpose of Git is solving a lot of those issues. Git is the most widely used distributed version control system. So that means that you can have a bunch of different versions of your code, and they are, the idea is you can attach a lot of documentation to each of your versions. So for example, like here we are attaching like the name of who did it, and then also what date it happened on, and then also it keeps track of every single change that person made. And now you imagine that you have it for every single time that that someone like pushes or is like happy. Like let's say they write a bit of code, they're like, all right, great. Like I'm gonna add this as a feature to this code base that I'm working in. Imagine now if we had a really well organized, well documented way to keep track of every single contribution to the code. So Git is extremely crucial in order to maintain safety in code. That's the whole purpose of Git. It's to make sure that that code is as bug-free as possible. It's just, this is the same exact sort of thing. It's like kind of like an IDE or like syntax highlighting. It's like just trying to help you write better code. Git is just trying to make sure that the code that you write doesn't conflict with like previous versions of code that you write or future versions of code. It's trying to make it all extra organized. I'm a big fan of organization, you know me. So yeah, Git is pretty awesome. Cool. Okay, I think we'll just hop into it a little bit. I'll pull up an example. Cool. So here is Visual Studio Code. This is my favorite IDE/text editor. It's great. Highly recommend it. Generally, it's the most popular at the school. Basically, every professor and student here uses it. So if you have any, if you're like, oh, I don't know, should I use like Eclipse or should I use Visual Studio or should I use CLion? I would say go for Visual Studio Code. It's the most popular at the moment. The most help is available for it. So anyways, that's a little rant. Visual Studio Code, really awesome. Okay. So let's make, I don't know, let's make something simple. Let's make a website. Yeah. Index.html. So cool. So if you know websites, so you start out by making index.html and then pull up that template and you can say example as the title, and then we can say as the header, like Git example. Great. Okay, so now we've made like a tiny little website sort of deal. Pretty chill, but I do that. Yes, great. Okay, so here's the website that we just made. Cool. So in this, we just have this one file. And if we want, we can make another file and we can make a bunch of changes and do a lot of cool stuff. Before we do any of that, I think it'd be better if we made this into a Git repository. So let's do that. Why is that? Okay, cool. So let's make this a Git repository. And the way that we do this is in your terminal here, we want to type git init. And cool. So now it initialized empty Git repository. So now this is a, this directory now is a Git repository, meaning that all of the files inside of it are now going to be maintained, and any changes that we make, once we like just do a couple commands, then they will be well organized and we can go back and view any of the changes later. And also, so it seems like a little bit like magic because it doesn't look like there's anything that changed in this. Like we can see that the file now is green, but by doing git init, it's like, oh, what does that actually do? So we can see if we list all of the files, even the hidden files, then we see that we have this .git folder. And this .git folder, this has a bunch of fancy files inside it that basically manage everything that, it manages everything in Git behind the scenes. So we can do like tree in .git. And so here are all the different files in .git file. And I won't go over these. This is more of like an introductory to GitHub and Git. So, but highly recommend watching the video on some of this. I just want to give you like a quick introduction to all these. But so yeah, you can just imagine that all of these files, they work together and then they create what is a Git repository. So, okay, cool. So now we've made this Git repository. So the next step is to actually add this file into the Git repository, because right now we can see it's green, and the green means that it is untracked, meaning it's a new file. So we've created this new file, but now we want to make sure that it's not like a new file. We want to have it so that it's like an actual member of this repository. And the way we do that is with git add. And so boom, so that creates, so that means that now index.html is about to be put into a commit. And then I'm going to do that next. So git commit. And then, so git commit -m. And so this, now we put our message. That's what -m is. So let's do added index.html. And the message, you always want to give an explanation of what you just did. Cool. So great. I just added this file and now it no longer is green. And so clear this. So what I can do now is I can do git log, and git log will show me all of the different changes that I've made. So here's one change. I added index.html. Great, cool. Let's do another change. That was kind of fun. So now let's try adding like a paragraph. So let's say like paragraph 1. one is here. So we can save this, and then cool. So it says paragraph 1 is here. So let's go and commit it. So first we have to add the file so that it will be in our next commit. So we want to do git add index.html, and we want to run that, and then git commit message, and we can say added paragraph 1. Okay, cool. So now we added paragraph 1. So now the file once again has gone back to saying like, oh, cool, yeah, I belong in this repository. Like I'm not altered at all. Cool. Okay, now let's try. Well, now let's try doing something kind of fun. So let's add another file, maybe. I don't know. page2.html. Yeah, cool. So we can say this is page 2. Okay, and then we can add a link. So we can say link, and we want to link to page 2. Cool. And then maybe on the other page, you want to add a link to page 1. Great. Okay. So now we have this working website. So page 2. So this is currently page 1. And so when we click on page 2, so we say this is page 2, and we can go back to page 1. And this is page 1. So this is, wow, what an awesome website that we just made. If you have any questions about this website, I highly recommend watching. I have a website tutorial series that I made through IEEE last year. So you can look into that if you have any questions on this. But now we have 2 whole files. So we have this file that has changes to it. And you can see that there's this little green line because we've added this line right here. And then this whole file is considered green. And so now we want to add these 2 things. So let's split it up a little bit. I don't know, that could be kind of fun. So let's do git add, but let's only add one of our changes. So that's a little bit hard, right? Because last time we were just adding like everything. So we were adding like index.html and but now we have 2 whole files. So we have 2 different options. Either we could do add index.html and then page2.html. I don't know. Or we could do one at a time. So I think it'd be kind of fun to do like one at a time. So let's do page2.html. So git add, and then we can do git commit, and maybe our message is added page 2. Okay, cool. So now we've added that. Now we can do git add index.html, and then git commit. Added link to page 2 because that's what index.html's changes. So great. Okay. And then if we do git log, then now we have all of these changes right here. Wow, we have so many changes. We have first commit is added index.html. Second commit is added paragraph 1. Then we added page 2, and we added a link. So this is really cool. So now let's say, oh, shoot, actually, I didn't want to add a link to page 2. Maybe I wanted that to be on a different thing. What I can do is I can actually go to a previous commit. I can go back in time and say, oh, let me just copy this hash, and I'll do git checkout. And then boom. So now I'm on this. So now once again, so we can see that that we don't actually have a link. So like if we refresh this isn't here. However, we can still go to page 2 if we want. Like, so we go page 2. So page 2 is still here, but when we go back to page 1, not because we got rid of that commit. But that kind of stinks because I liked how it was. So let's bring that back. Let's do C and then git checkout master. And that will bring us back up to whatever the like most recent change is. Cool. So now we have all our changes back. And yeah, so that was just like a little bit of an intro to that. No worries if you didn't catch it all. Like, this is so easily forgettable. You don't really even need to know this because Git is really hard. So I'm going to show you an alternative to typing in all these commands. These commands kind of stick. These are the easiest and ones that I would recommend that you learn, but you don't really have to learn anything past that because you can just use a GUI, and GUIs are so much easier, and it's all about code safety. It's all about like what is the best way for me to make sure that my code is organized. And if you're comfortable using all these commands, then yeah, go for it. But honestly, 9 out of 10 people are probably just going to use a GUI because it's safer and it'll ensure that you don't accidentally mess up a single command and now you've like deleted half your repository. Yeah, but Git commands are really hard. So here, if you wanted to, you could go and look more into Git. So here is a reference guide about every single thing that there is to know about Git. I don't even know like a lot of this stuff. It's kind of, a lot of it's like not actually used by many people. A lot of it is really important and should be learned. If you want, you can go through all this. It's a 500-page like manifesto of Git, and it kind of stinks having to read that much. I don't know. I just do I only do what I need in my time, and that's what I would recommend. Is like as just things, I would just say start using it right away. Don't get hung up on like how hard and confusing things are. Just get started with it. And if you have a question, go and Google it and keep going, and keep going, and keep going. And that's how you learn things in general. It's like, yeah, you're not going to learn Python by like reading a book on it. You're going to learn Python by writing Python. You're going to learn Git by doing Git, not by just reading this. So that's my recommendation. But it's here if you want it. It's in this link right here. Yeah. So with that said, I highly recommend just installing GitHub Desktop, because GitHub Desktop is a really great way that makes it so you don't even need to use like any of that, any of the like commands in this. And let me show you. So GitHub Desktop. Now let's open up the Mapache. So this is GitHub Desktop. And it's for Mapache. So here's these really convenient links here. So we can open up the repository and Explorer, so we can see like here are all the files, like all my GitHub stuff, and then or we can view on GitHub. So here is the repository on GitHub, and or we can open up in Visual Studio Code, best text editor. So yeah, so if I wanted to, let's go and like change something, I could go in and like type something funny, and then yeah, and then so I just made a change, and then here GitHub Desktop, really convenient, and it just shows me the change right here. So if I wanted to go and maybe change like a few other files, like I wanted to like change like this, and then I wanted to change like in the hardware level, I want to like change like some of the Verilog, yeah, mess that all up. Let's say I'm like trying to go around like wreaking havoc and just adding bugs. It's pretty easy to just find out like who committed. If I wanted to go and commit this right now, I could, and it'd be really easy to undo it because like it's all it's all well organized and documented. And every single change that I've ever made is all documented here. And I have about 400 changes to this repository. And yeah, so you can see every single change. You can see, oh yeah, on this thing, I edited the README. On this, increased the firmware version. And here, oh, I made a bunch of changes. This one, I like moved this file, and then I deleted that file and created that one. And this one, I made like several changes throughout the file. So this is really, really convenient. GitHub itself also offers similar features. Let me just discard all these. Discard. Yeah, and you could discard changes. You see that? I like typed all that crap, and then I could just hit discard, and it all like undoes. That's so nice. If you like are just tired, you're like, oh, you know what? Like screw all these changes that I made. I'll just like work on it later. You can just discard everything and not even have to try to debug what you did. Yeah, and let's look at GitHub a little bit. So yeah, so you can see all the commits here, and you can see like, oh, so I centered the header, and this is how I did it. Great. Cool. So yeah, that's a little bit about Git, and yeah, but now I want to talk a little bit more about GitHub. So does anyone know? So we've talked about Git. Yeah, by pop quiz. Can anyone give an explanation of what Git is? So Git is important for managing versions. However, Git itself is not actually connected to the internet. And so that's a big difference. That's a big reason why GitHub is so good. It's because GitHub is a way that you can organize all of your Git repositories online. GitHub is super cool because if I code something on my computer, I'm like, wow, this is a super cool app. I put hundreds of hours into it. I love it. This will be great to put on my resume. I'm so excited. Yeah, woo. And then, but there's no way, like the only way for me to actually show it to people is to put it on the internet for people to look at. And that's what GitHub is so good about, is I can put on the internet all my code, and it's organized in such a beautiful way because of Git's functionality. So Git and GitHub go hand in hand. GitHub is just a hosting service for, and I think I have to study about this. Yeah, so GitHub is a repository hosting service. And what's so great about it is it's used by millions of people, and as well as thousands of companies. So basically any company that you apply to is going to know what GitHub is. Or yeah, any company that you apply to is going to know what GitHub is. So if you have a bunch of repositories on GitHub and you say, oh yeah, I'm experienced in Git and I use GitHub to organize all of my repositories online, they're going to be impressed. They're going to say, wow, this is someone who understands how to create a good product. And we need that for our company. And great for showcasing projects. So if you have a bunch of projects and you want to show people, GitHub is just a fantastic way of yeah, and you can see here. So this is my, let's pull up my GitHub. So this is my GitHub page, and I spent yeah, I don't know, maybe probably 1,000 hours on all my different projects over the past 4 years. And here are some 6 of my most impressive projects that I've done, or at least projects that I think employers would be most looking for. So I have here like a JavaScript, or I guess that is the arcade machine, Apache. There's like a lot of Verilog stuff. Here's a lot of C++ stuff. Here's like a binary parser for WAV files. And then here's a website for IEEE classes, pretty cool. Here is a thing I wrote for an STM32. You'll learn about that when you're taking ECE 153B. And then here's a Verilog library that I wrote. It's pretty simple. It's like 50 lines of code. But yeah, but this is like it's very pretty. Like I have like a nice description about myself, and I have a profile picture, and it's all pinned, and like I have like listed, like here are all the different contributions I've made. So in the past year, I've put in 1,000 contributions. Wow, that's a lot of contributions. So highly recommend if you have a few projects on your computer, even if they're not even that cool. Like I have a few projects on this that are like 6 lines of code, but I'm still like I want to just keep it organized. Like because Git and GitHub are so good at organizing it. If you just have a bunch of repositories, it'll give you experience working with Git and GitHub. And if you have a project that is actually cool, you can put it on here and then display it to people. Yeah, I'm going to skip ahead a little bit, and I want to just give you a demonstration of what GitHub can do. Hopefully I can finish in 18 minutes. Cool. Okay, so let's make a new repository. So let's say you've made your GitHub account. And we're going to make a new repository. So this repository is going to be it's a Git repository, and it'll be hosted on GitHub. And let's just call it Hello World, because that's pretty cool. Hello World, and I'll post this after we're done with it. And so let's create this. And cool. So it's public repository, so anyone can see it. I'm going to click Set Up in Desktop so that it is set up in GitHub Desktop, which is super cool and easy because I like GitHub Desktop. And clone this. And cool. So now here is this repository that I just made. And there's no files, right? Because I just made this on GitHub. But now what I can do is when I open this, let's make a simple hello world. So hello, oops, here. And keyboard is okay. Hello world.py. let's do print hello world. Cool. Okay. There we go. Okay. And so now if I do Python 3 and hello world, great, hello world, pretty simple. So next, it would be really cool if this was on GitHub, because that's all. So let's do that. And if I wanted, I could do git add and whatnot, but I'm going to cheat and I'm just going to use GitHub desktop. That's way easier. So I'm going to take this. I'm going to say, yes, create hello world and commit to main. So cool. So now I've just committed this. However, I've committed it, but it's not yet on GitHub. So it's in this repository. I could do git log, and I could see that we have the commit. But if I go on GitHub and refresh, it still says that it's empty. So next step is we need to push it. So, and the way we do that, so first I need to publish this, and then, so cool. So now I have pushed my changes to GitHub. So if I hit refresh, then now all of my files, so you can see my file right here, it now exists and I can open it and we can see hello world. Great, cool. So this is pretty cool. So now we have a whole hello world program. And if we want, we can make this look a little bit cleaner. We could add a README file so that it's more pretty. We can also kind of get rid of these things because they're not important. Add a little description, hello world program. Okay. And we could say the topic of Python. Python, great. Cool, so now when anyone comes to this, they can see, oh, okay, so this repository uses Python. Oh, it's a hello world program. Oh, cool, okay, let's look at their code. And wow, they really know how to code a cool program. And yeah, cool start. But then they'll say, oh, but this doesn't have a README file. So let's add a README file, see what that looks like. So, cool. So add a new file and readme.md. MD stands for Markdown, just a good file type, similar to like HTML. It's markup language. If you have questions about that, let me know. Similar like LaTeX, all of those are like markups. Okay, let's call it hello world. Okay, and this is a hello world program. Okay, and another good habit to get into is just to put a link to the repository in the README. Cool. So now we've made this README file, and so if we go and paste or add this, so we can commit this, and then we want to push. And when we hit refresh, then what's cool? So the README file, we just added this, but it now will display here. So anytime anyone will click on this, they will immediately see our README file here. And if I wanted, I could go and change this more, and then it would all appear down here. So README files are very important. I highly recommend that you just, that every single repository that you have has one and has a little short description of what the repository is. It'll win you so many points. If you have someone who's trying to interview you and they're like looking through a couple of your repos and none of them have README files, that's basically as if you hadn't written any code at all. But it gives you so much more like credibility if you give a short little explanation of what your code does, or maybe even how to compile your code, or what other tools you've used in it. And just look at other README files and other repos if you have questions on that. Okay, wait, there's a question. Sorry, I don't know when it was asked, but what's the difference between commit and push? So commit is when it's added to the .git folder. So if you remember, so there's a .git folder here. And so when we do commit, we add all of our changes to this .git folder. However, those changes are not on GitHub. Like they're not on someone else's computer. They're not like on this server. So, so the way that we make sure all of the changes that we've put into this .git folder, we want to make sure in order to get them to go to GitHub, we have to push. So that's what push does. Push takes all of your changes in Git in your .git folder and puts them in the changes in the whatever in the .git folder of GitHub. Yeah, so that's the difference. And when you can also do git pull, like let's say, yeah, let's do that. So on GitHub, you can actually go and edit any of the files. Let's do that. So this is a hello world program. Thanks for checking it out. Great. Okay. So I added this, and so now I can commit this. So cool. So now I've added this. However, now these two repos are out of sync with each other. So then what I can do is I can do git pull. And I won't do it here. I'll do it on GitHub this actually. Yeah, so it even sees, so it says pull origin. So it notices that on GitHub, there was actually a change. So I can click pull origin. And then now, boom, so it added our change that we made on GitHub. So git pull and git push are the ways that we keep our things up to date with Git and GitHub. Cool. And does commit keep changes in a to be committed list? No. So commit literally adds it to your Git folder. However, those are not on GitHub until you do git. Cool. Okay. Great question. That was a fantastic question. Yeah, I feel like I'm kind of rushing through a bit of it. Maybe it should have been longer than an hour, or my slides should have been clearer, but that's okay. Next thing, it'd be super cool is if we had a website. So let's say you spend a lot of time making a really cool app and you actually want to have your own website. GitHub makes it stupid easy to do that. And I'm going to show you right here how to do it. So all of you can make a website right now if you want it. And all you have to do, so you have to make a new folder. It's called docs. And maybe you have to call it docs. And then inside this, you want to call it index. And you can say .html, like when we were making the website earlier, or we can do markdown. And that's like the easier way. GitHub converts it to HTML for us, which is really nice. So let's just use markdown and we can say, hello world website. Great. And welcome to the website. And then here we can have a link to the repo. Is there a question? Question? Okay, cool. So cool. So now we've added this file. So let's go and push it really quick. Added a website. So let's push that and let's view it on GitHub. Cool. So now we can see Zoom's in the way. Okay, so now we can see this docs folder and index.html. So this is the file that we just added. And now we want to have it be on the website. And we can do that by going into settings and setting that up. And we go to pages. And then for source, we want to pick the branch that we're working on, which is main, and then docs, and then hit save. And then enforce HTTPS. Now that we've done all that, that's all we had to do. Now, so it's building right now. It's just trying to get it online. So we just have to wait for just a little bit. Almost ready. Oh, you know what? Let me show you something. So I said that GitHub is used by millions of developers and thousands of companies. Can anyone think of any companies that use GitHub? Or can anyone think of any projects that might use GitHub? I don't. Does anyone know about Dolphin, the GameCube and Wii emulator? Yeah, few people. Yeah, I love Dolphin. Dolphin, huge emulator, thousands of collaborators. That uses GitHub, and we can find it. Dolphin, and first thing. Great. So this has 36,000 commits, and 500 collaborators, And so here we can see the README for it, and it's all very nice and pretty. So this is an example of what like a nice README is. Yeah, so you can imagine like this needs to use some sort of like nice organization thing. And it's really easy because now we like here's the website. And yeah, you can see this docs folder. So docs folder, that's how you make a website. So this link right here probably goes to that docs folder. Another thing, so someone said Linux Foundation. Yeah, so I might even have it. No, okay. Linux. Oops. Great. Here's Linux. So if anyone's heard of Linux, here it is. Million commits. Yeah, so you can just go and like download this if you want. Super cool. You can just look at all the code to Linux. It like kind of blows my mind that I'm like writing code on the same website that like Chromium also is on GitHub. Yeah, it looks like the website is ready to be published. So let's open it up. And cool. So here's this website, and it was just created. Everyone can go and look at this if you want. Great. So if you've never made a website before, this is how to make a website in about 5 minutes. Is on GitHub. GitHub makes it so easy, super nice, and this is really great because like Mapache. So this is the IEEE arcade machine project. This repository is in the docs folder, which is great because like if we have anything that we want to talk about, like guides, like talking about the GPU, we have like a whole documentation of how the GPU works. And so if anyone has any questions on it, even if you're not a collaborator, but if you just wanted to find out more, we have a whole website for this. And then we have like games, so we can see like like a link to the asteroids game. Yeah, so super easy to make a website. Let me know if you have any questions about setting that up. This is just a quick like overview of what is possible with GitHub. Not going super in depth on things. Everything's pretty easy to Google. Things are pretty well documented, and the community is very nice. If you have any questions, there's a lot of forums that you can post on. Yeah, okay, the last thing I want to show, hopefully I have time for this. Something super, super cool. Hello world, probably not gonna break. But let's say someone came along and accidentally inserted like some sort of character in it. So now it no longer said hello world, but it said hello world G. That's a big problem. Let's say like thousands of people were relying on this to say hello world, and you just broke it. Now thousands of people are going to be really angry, and that's very sad. So what we can do is we can add a test for it. So we can say, let's make it like test shell. Okay, so inside this we can run our Python file. So we can do Python 3 hello world.py. We can save this, and then we can do bash and test.sh. Okay, so when we run this, then it will also say hello world. Okay, so this is the all this is just running it, all the commands. And now also what we can do is we can make a variable, so we can say the expected output equals, we can say hello. Wait, this is the wrong file. This one. Okay, the expected output is hello world, and but the actual output is equal to, and we can take this and we can run this command using this notation. So now if we can echo this, meaning like print, hopefully you're all super familiar with bash. No worries if you're not. Cool. So do expected output is that, and then actual output is that. Great. Okay, so let's run this now. Okay, there we go. So expected output is hello world, and actual output is hello world. So great. So we can just add like a little assertion here. We can say that if they are not equal to each other. So expected output does not equal actual output. Then we can say go test failed. Great. And then exit one and then end the it. Okay. So if we run this, hopefully, yeah, it doesn't say any of that. But let's say we were to change this, we say, oh, let's say no more comma. Okay, so no more comma. So now we'll say test failed because the Python thing had a comma. So if we now get rid of the comma, then it should once again pass. Great, it does. So this is just like a little tiny script that is just really easy to, it's just a quick little test to make sure our code works. And so I can add this if I want. But what's super cool is that GitHub has a continuous integration feature where you can run this test every single time that you push. And so let's add that really quick. And I'm going to go into this. So I do not have this file memorized. This is something that you can look up, or you can take from the repository that I'm going to post on the website. Just a second. And then close. And then okay. Cool. So what this file does is, all it does is it makes sure that it's on the correct version of the code, and then it will run this test.sh file. And when it runs it, if it does exit one, then we will see that the test fails. But if we see exit zero, which is implied always at the end of programs, if we see exit zero, then we pass successfully. So let's do this. So we've added this test and we've added this. So now we can say, so added tests, and we can commit and push. And now if we open this up, I'll just do that. Zoom is in the way. Okay. Great. Okay. So here we can see all of the tests that we did. So when we did the commit, added tests, we ran the test that we added using the script that we just added. So yeah, so run test. So this is the thing that we just put right here. Yeah, run tests. See, so yeah, so run test. So it says expected output hello world, and the actual output was hello world. So we passed the test, so we're good. So we got this green check mark, which is super handy because let's say someone came along a little bit later, and let's say they changed the Python code. Oh no, what's going on? So they changed this, and it says like goodbye world. Menace to society. So they say that, and they go and they print this, and they push it. So now if you refresh, so you can see that it's currently running the test. So the checks haven't completed yet. And if we click on it, it's running it. And I guess it's waiting for a computer. Okay, there we go. So it's starting it. Oh, it ran the test and it says test failed because the actual output was goodbye world, but the expected output was hello world. So this is convenient because now you can see, oh wait, there's an error with this code because right here we see an X. A lot of repositories have that check mark. I can't think of any off the top of my head. But it's this is very widely understood. And so if you have a green check mark here, that means that you have taken the time to add tests to your code, which is another huge step. So let's say, yeah, employers coming in, they're checking out a bunch of code from people. Let's say they come in and first they see, oh, wow, it's like very organized and clean. And and like here are all the files and the commits are very well organized. Oh, they updated this and they added tests and they added a website and then they created that. Okay, very, very nice and pretty. And then, oh, wow. And they also have tests, which they're running all the time. So now we know that not only is their code organized, but it also passes the tests that they wrote themselves. And tests are so important. On testing software takes up about 70% of all software development time nowadays. And as things get more and more advanced, the amount of time spent testing is actually going up. And so it's expected in the next 20 years, maybe 90% of all software development time will be sent into testing, which is pretty crazy. So if you say like, oh yeah, like I test my own code, you're immediately going to get an interview most likely. So yeah, make sure you add some tests to your repositories. Yeah, if you have any questions, please message me or put them in the Discord. Send me an email. Come to my office hours. I have office hours Wednesdays. But I think we're basically done.